Welcome to Intro to Proofs, section 4.1. Now we're going to do progress check 4.3. So for this progress check, we have the universal set is 1, 2, 3, 4, 5, 6. A is 1, 2, 4. B is 1, 2, 3, 5. C is all the things in the universal set such that squared is less than or equal to 2. Okay, we're asked to fill in some blanks. So A is, so we can use subsets. Now, is A a subset of A and B? So is A a subset of B? No, because A contains 4 and B does not. Is B a subset of A? No, because B contains 5 and A does not. So these two sets are just not equal. There's nothing else we can do with them. Okay, 5 and B. Okay, well, 5 is an element of B. Nope, sorry, I got carried away. 5 is an element of B. All right, and then A compared to C. Well, what things are in C? C, things from the universal set that when squared are less than or equal to 2, that would just be in the number 1. So really, let's simplify C. It's this. Okay, so A contains C. And really you could use strict contain. So you could have also said strictly contains. Both of those are correct. All right, 1, 2, 1, 2, 2 in A. 1, 2, 2 is contained in A because sets, if you have repeated numbers, they just count as one thing. 6, that is not an element of A. So put a slash to the element symbol. Empty set. The empty set is always a subset of everything. So it's a subset of A. The singleton set containing 5, that is a subset of B, not an element, a subset. 1, 2 compared to C. Remember that C is really just the singleton 1. So this contains C. You could also write that it strictly contains C. All right, 4, 2, 1 in A. 4, 2, 1 in A. Well, those are equal. They're the same set. Okay, and then B and the empty set. Well, the empty set is a subset of everything. So those are both correct. All right, let's move on to progress check 4.5. So this, we've got U equals the integers, and A is 1 through 10. And B are the integers that are less than or equal to 4. X is less than or equal to 4. Okay, so now what is 1? A intersect B. For that one, let's use the roster method. Sorry, let me make it so you can see. For A intersect B, let's use the roster method. So 1 through 10, but that are less than 4. Well, that's 1, 2, 3, 4. And 2, A union B. Okay, this is an infinite set because this is infinite. There's lots of negative numbers that are in there. All the negative numbers are in there. So we'll just extend it up to 10. X, here's the set builder notation, X and Z, such that X is less than or equal to 10 now, instead of 4. So that we get all of those and all of these. 3, A that is not in B. Not in B. Well, that's equal to, basically, the things in A not in B would be 5 through 10. I got lazy there. I could have just done 7, 8, 9, whatever. 4, things that are in B but not in A. Things that are in B but not in A. Well, that would be, let's use set builder notation, x in integers. So these things are less than equal to 4, but not 1, 2, 3, or 4. So x is less than equal to 0. 5. A complement. Okay, there's a couple ways to write, let me make it so you can see. A complement. There's a couple ways to write this one. We can use roster method. So that would be use like -2, I need it, ... -2, -1, 0, and then jump to 11, 12, 13, ... So as long as you say, hey, the pattern continues, I'm counting down, I'm counting up, it's messy, but it's okay. The even better way to do it would be to say x in the integers such that x is less than or equal to 0, or x is greater than or equal to 11. That'd be the better way to do it. 6, B complement. B complement are things that are not in B. So that'll be x in the integers such that x is greater than 4. When you got, oh man, that's awful, curly bracket. When you got set builder notation, you can just negate the condition and you have the complement. All right, that completes progress checks 4.4 and 4.5.